I'm Anil Kumar. Welcome to my series. Here in this video, we will try to understand a relation between exponential and logarithmic functions. We have a graph of an exponential function here. Since the graph drops down rapidly, it is exponential function with negative exponents. This kind of shows decay, exponential decay. To find the equation of the exponential function from the graph, what we can do is we can look at some points, right? So anything to the power of 0 for an exponential function is always 1. So we get the first point. Now in this particular case, to the power of minus 1, we get 2. That means the base is 2 for us, correct? Now to be very sure, let's investigate exponent minus 2. It gives us 4. So we are very sure is going by the multiples of 2. Therefore the base has to be 2. So what we really get here is an exponential function which is 2 to the power of minus x. Well, at times you can also write this as half to the power of x. Both are same thing. So that is the exponential function which we are discussing. And as you know, logarithmic function is inverse of exponential function, right? So if I find inverse of this function, we get the logarithmic function. Inverse of this function will be y equals to minus log to the base 2 of x, correct? So that is how we could write inverse of this function. At times we can also write this as, looking into that function, if you write half to the power of x, you could write this as log to the base half of x, right? Both are the right ways of writing the same equation. If we are considering half to the power of x, this could be an easy way to get 2. But if you are writing this as 2 to the power of minus x, then minus log to the base 2x is the right way of writing the logarithmic equivalent of your exponential function. So what we have also learned in these 2-3 steps is that how to write exponential function as a logarithmic function, right? Now next thing which we want to study here is check the key points which we should be considering for graphing these functions. Well, for exponential functions, you know the key points. Let me list them here quickly for you. The key points are, always we have to look what happens when x is approaching negative infinity, what happens when x is approaching positive infinity. Those two are very critical points for any function in general. The other points are, we can start from the middle. What happens when x is 0, when x is 1, or when x is 2. Similarly, at x equals to minus 1 and x equals to minus 2 are good values to check for us, correct? Now in this particular case, when we are looking into the function, which is, let me say, function for us is 2 to the power of minus x or half to the power of x, either way, in that case, the values should be, for x equals to 0, x equals to 0, we know it is 1 for exponential function. Exponent is 0, that means the result is 1, correct? Now for x equals to minus 1, we have 2. For minus 2, we have a value of 4. All these values are actually greater than, they're all positive, right? Now for 1, since it is a decay, it is like 1 over 2, it is half, right? For 2, it is 1 over 4. And as x approaches positive infinity, y actually approaches 0. As x approaches negative infinity, y approaches positive infinity, right, in this particular graph. Now, let's investigate the logarithmic function. Now, for a log function, which I could write as log to the base of half of x or minus log 2x, right? Base is 2. Now writing in these forms is kind of interesting. So when I say base is half, that means the value of the function at half should be 1, right? When these two are equal. So at half, we are expecting a value of 1. So we're kind of expecting it here, correct? At 1 it is half. Another way of looking into it is that to get to the inverse of decaying function, we could actually do reflection on x-axis to get the graph, right? So we have already done log of 2x. So if you graph the log 2x function and reflect it on x-axis, you get the graph for log of half x, right? So it's kind of interesting to look into this equation in both ways, and I hope that is going to help you in the long run, correct? Now, to get to these points, what we can also do is we can flip these points and write them. So we get the coordinate points as 4 minus 2, right? So we are literally doing inverse by flipping x and y values. So we get 2 minus 1, 1 comma 0, half 1, 1/4 2, and as x approaches infinity, y approaches 0. That means as x approaches, I should say now here, as x approaches 0, y approaches infinity, right? So that is how it should be. It just interchanges. Do you see that? So similarly, we can write here as x approaches positive infinity, right? In that case, y approaches negative infinity. Does it make sense to you? So that is how it is. Another important thing is that this particular is the invariant point. Whenever x is equal to y, then y is equals to x for the inverse of the function, correct? So that gives you kind of a hint of how to draw this graph, correct? So we can plot these values. So 4 is minus 2 for us. 2 is half minus 1 for us. Okay, so we already have this. And at 1 we expect a 0, right? As we go closer to this place, we can get to these points, correct? So these are the good points to look into, right? So we can always draw these points. So if we would have gone further, for example, if x equals to 3, we would have got 1 over 8. So we have 8 and 3 here. So for x equals to, this is the wrong point. For 4 it is minus 2. Yeah, 4 it is minus 2. And at 8, the minus 3, sorry, minus 3. Let me write. So I should have got it there. So minus 3 will be 8, right? So 8 will be minus 3. So 8 and minus 3. So I'm just trying to get one more point, which is kind of away here. Anyway, so what we can do is we can just connect these points and then get our exponential function. So that is how this exponential function is going to be. Let's forget about this. Okay, let's use the points which we have. Okay, and that is how we have. Yes, I just wanted to get that point. Anyway, so what we get is that kind of a graph, and this graph is for log to the base half of x, or you could also write this as minus log to the base 2 of x, correct? So if you reflect your logarithmic graph with the base 2, you get minus log 2x also. So here what you learn is that you can actually get the graph of log of bx. You can use the log, what I'm saying is you can use log bx graph to find log of 1 over bx graph by making it negative. Do you understand? By reflection on x-axis. That is a very key thing which we are trying to learn from this video, in addition to whatever we've done, right? So now you can write down domain range for your exponential function and logarithmic function and see if they are inverse of one another. The domain range should also flip, right? And we've already seen that this line y equals to x can be used to reflect exponential function and get your logarithmic function. Anyway, so we have done a couple of things here. You can go through this video, understand these points, and then answer the questions from your book. I think that should be very simple now onwards for you. Let's move on and now evaluate logarithmic functions. Thank you and all the best.